Hello everyone, welcome to the Sprint 2 review presentation of our team Rush Hour. So coming to the agenda of this presentation, we'll be giving a brief introduction about ourselves, the team role and the responsibilities, and we'll be discussing about the project overview as well, which includes the problem statement, description and the agreement in the team and the personas which you have required for making this project and the design of the project. And we'll be giving a briefing about the technologies used and the product backlog which you have considered to make this project work, and how we have determined the sprint and the user stories which are related to the sprints. And also we'll be discussing about the sprint 2 retrospective and the sprint 3 planning as well.
Hello, myself Avinash Manchala. I'm working as a full stack developer and UI UX designer of our team.
This is Ratanjanath Semvarku. I'm the team lead of Team Rashore and also work as a Scrum Master and the full stack developer for the team.
Hi, this is Kaundinya Vadapati, and I'm working as a full stack developer, and I'm deal with front end, back end, and database of our application.
Hi, this is Saira Madala. I'm working as a full stack testing engineer.
Hi everyone, this is Pranay Kumar Reddy and I work as lead AI ML developer for the team.
Hi, this is Uday. I'm working as AML come tester.
Hi, this is Murli Kumar and I am working as AML engineer and tester.
Hi, my name is Sujit Suprabhat Tukki. I'll be working as a full stack tester and quality assurance manager.
So coming to the improvements from the professor for the previous sprint. So based on the professor feedback, we had improved the features, technologies and tools slide. We also improved the product backlog slide by adding titles and removing the features. We also improved the metrics to include various other things as well because we considered stories in hours instead of points. And we also improved the test cases slide as well. And coming to the problem statement. So healthcare today can be really overwhelming for both patients and medical staff. There's so much data to keep track of, from the test results and diagnosis to appointments and prescriptions. Patients often lose track of their own medical history, and hospitals have to deal with endless paperwork. It's clear we need a more modern, streamlined way to manage healthcare information, something that can reduce manual work and help doctors make quicker and more accurate decisions. So that's where our project Uspark comes into the play. Uspark, it's a smart platform that uses machine learning and an intuitive design to handle everything from scheduling appointments to storing medical data. A big part of is UHIL, our AI chatbot, which can ask your assessment, your details, and everything. And it can also schedule an online consultation and in-person visit as well. And coming to Uspark, it's not just for patients. Doctors can also use it to organize their schedules, keep track of patient records, and even use the built-in ML tool USEC to analyze biomedical images and diagnose various different diseases as well. And this is the template for the product description.
Okay, so this is our team working agreement. These are all the terms that we have agreed as a team. Brief description of the agreement is that our team rush hour is driven by the aim of producing viable result at the end of the project duration, striving to give our best to meet pre-decided plans and goals and ultimately ensuring customer satisfaction. So I'll be going through each of these terms. Individually, each member is responsible for their task. So individual accountability has, this is a big project. We as a team, each individual in the team will be doing their part, understanding the importance of the contribution. Second is communication and resource sharing. So as a team, we use different tools for communication such as Zoom, WhatsApp, Google Docs, and other software to facilitate collaboration. Third is participation. We have all agreed to participate and be active. Then is openness and helping. All the team members have agreed to help each other if someone is stuck at something. Then it's the work division. Work is assigned to all the team members according to their interest. Then the meeting we as a team have decided to connect with each other on Zoom, and also based on the sprint schedule given and sprint planning, a sprint retrospective is conducted to examine what went well and what other improvements are needed. Thanks.
Yeah, coming to the personas, We have dealt with the four persons. Here comes the persona one. The first person is Miss Dr. Sarah John is a 40-year-old senior radiologist at NYC Health Plus Hospitals in New York, dedicated to providing accurate diagnosis while managing time efficiently. He faces challenges such as spending excessive time manually reviewing medical images, dealing with unstructured patient history and reports, and struggling with inefficient appointment and scheduling management. To overcome these obstacles, she seeks a powered tool to assist in faster and more accurate diagnosis, a centralized system for easy access to patient history, and a well-organized appointment and consultation management system. Coming to second persona, is Mark Thompson is a 45-year-old bank manager at TD Bank in New York who is devoted parent striving to efficiently manage his family's healthcare. He faces challenges in keeping track of family health records, balancing work with healthcare responsibilities, and lacking a system to monitor recurring health issues. To address these issues, he seeks the best way to access and organize health information, a straightforward approach to tracking symptoms and past treatments, and a more efficient way to navigate healthcare of his family. Coming to third persona, Emily Carter is a 38-year-old lab technician at NYC Health Plus Hospitals in New York, responsible for ensuring smooth healthcare operations. She faces challenges in manually managing a large volume of patient appointments, preventing doctor schedules from being overbooked, and efficiently keeping track of patient medical records. To streamline her workflow, she seeks a system that simplifies patient bookings and cancellations, provides easy access to inbound and outbound patient records, and integrates seamlessly with hospital management systems. Yeah, coming to fourth persona, Lisa Brown is a 32-year-old software employee at Accenture in Brooklyn who values convenience and reliable health guidance. She prefers to make informed healthcare decisions without unnecessary hospital visits and seeks trusted medical advice instead of relying on internet searches. While she doesn't frequently visit hospitals, she occasionally needs medical guidance and desires flexible, on-demand healthcare services. Lisa's primary needs include access to reliable medical information without appointments, a way to consult a doctor only when necessary, and a better understanding of symptoms and health concerns. Yeah.
Based on the user stories, we designed our application, the main core features, booking appointment, hotel recommendations, chatbot, on card, and usage. Booking appointment means you can book appointment with doctors as well as they can receive appointment schedules and everything from the doctors, and doctors can have choose their availability also. And hospital recommendations based on the location, you will get hospital recommendations from chatbot as well as from outside of the application as well. And chatbot, for the chatbot we will get initial assessment from the chatbot, and also they will suggest doctors based on it also. And one card, this is for the doctors. I mean, doctors can view entire details of their patients all at one place, including insurance details and overall everything, past assessment and everything files about it. And when it comes to the usage, doctor can upload images for getting the biomedical image segmentation, so they can easily find out the disease which is there in the picture, I mean the parts. Next. And this is a product design. Then when it comes to the login as a doctor and login as a patient, we design two types. And the second screen represents doctor profile dashboard, and the third one is USEG. Doctor can upload photos to the USEG and they can see the biomedical image assessment. And fourth slide represents the chartboard assessment where patients can take preliminary analysis from it. And next one. And this is a patient dashboard. And when it comes to the last one, this is the one card we have discussed earlier, and it has all the details, insurance details, previous assessments, and everything. Yeah, this is about the MVP design. Yeah.
So now comes to the technologies and like the tools which I have used. So for front end, like we have used like React, and we also use Material UI for like creating good type of like stylings and everything. Uh, with respect to Axios, it's like actually like the connection between the front end and back end. We used Axios to call the thing, and Redux we used to store the data, and then coming to Node.js, which is used for backend. And here we have created the APIs with using Node.js and Express.js, and we use Python for like developing the algorithms and everything. And maybe you can go to next slide. The database we have stored like MongoDB. So our entire architecture is in man. And apart from that, like we are using AWS, so to store the S3 bucket of images and everything. And coming to TensorFlow, PyTorch, Flask, so we use this for like creating the chatbot and then the ML AI algorithms. And maybe you can go to the next slide. Yeah. So the Docker, which is we are actually using the containerization of like uh, creating the images and then publishing in the Vercel or render platform. And coming to Jira, where we are actually planning the entire like the flow which we want to like the testing part, who gonna be like working on what are the things. So the editors we are using VS Code, as we are familiar with that, like, and Figma is used for like designing for us, and Postman is also like the API testing, and we are right now storing the data in GitHub now. Yeah.
Yeah, coming to the algorithms and models, we started with the RAG, which allows the chatbot to search documents and then generate accurate knowledge-based responses. This helps and provides users with the reliable medical information, not just generic answers. And for analyzing medical images, we use DenseNet, a model that reuses features efficiently and making image process faster and more accurate. And we also added ResNet, which helps solve vanishing gradient issues in deep networks. This improved our systems ability to detect issues in medical images with greater precision. Finally, to make our chatbot more conversational and engaging, we use the dialogue GPT. This allows UHeal to interact naturally with the users, just like talking to a real person.
Yeah, so coming to the diagrams. Next. So this is our architecture diagram. So the architecture diagram can be divided into front end, back end, and also from the patient's and the doctor's perspective. So it's quite evident that we need to store all the details. So the storing things which we have considered on MongoDB and S3 buckets. So using the MongoDB and S3 bucket, we'll be storing all the details like the user details, their email, and everything will be storing in the MongoDB and their onboarding status as well. So the S3 buckets are preliminary used to store the images. So if an doctor uploads any image to the ML algorithm, then the images are needed to be stored and the profile images and everything are needed to be stored. For this purpose, we are using the S3 bucket, and also for documentation storages, because the documentations which are obtained as a part of the past medical history and also as a part of the doctor's verification, they are also stored in the S3 bucket as well. So the patient consists of main few four things. So one is the medical news, and there is the initial assessment, which is ultimately saved in the one card. And the third thing is image uploads, which he makes through the UHeal, and then also we are using the Flask and LLM as a part of UHeal, because UHeal is an intelligent chatbot, so we are using that. And considering the doctor, so the doctor consists of unit, CNN, and USEC, which is basically our smart ML assistant, which is used to segment the images. And also it's common that we can see the medical news and the both the patient and the doctor as a part of. Now we haven't implemented the medical news in the doctor's page, but we are going to implement that as well. Coming to the admin consists of only one function which is used to verify the doctor's profile. So the doctor uploads their documents and everything, that the verification status as well needs to be saved in the MongoDB, which we can see here as well. And coming to the backend part, there are few APIs. So all the routings and everything, we are using the APIs, and also we are using in places Google Places API to get the location, so that we can see the nearby hospitals, and a medical news API to display medical news on the pages. So next. So coming to the context diagram, I've made a few changes to the context diagram based on our professor's feedback. So it's a much simpler display of our context diagram. So we can see the directions over here. So the inputs are presented in green color and the outputs are presented in a darkish brown color. So uh, so considering over here, like the doctor and the patient, so the patient can actually make their appointments and their upload their images as well. So and they get an receive their preliminary diagnosis as well as a part of their diagnosis, and also they receive the diagnosis from the doctor after the appointment is completely done, and they can also make the appointments. So we have considered making an appointment system using an external approach rather than using a chatbot approach. We are trying to implement the making appointment feature using the chatbot as well. Soon we'll try to implement that as well. And coming to the doctor part, the doctor can upload those images to USEC, and also they can receive their processed output. And coming to the diagnosis report, they can send to the diagnosis report to the patients as well, and also receive the patient's details, that is appointment details. Also they can receive as a part of our Uspark application. Next. So coming to the sequence diagram, there's a sequence of things happening in the entire application. So here also we can see the patient, doctor, and the admin's perspective over here. So coming to this, we have few parts. Like in the front end part, we have use UHIL and USEC for the patient and the doctors respectively, and in the back end part, we have the Mongo and S3 and MedNews API. So we are adding in Google Places API as well. And so we can see here using eHeal, the patient can chat to take initial assessment and update the one card and make appointments as well. And then I can also upload images for diagnosis. That's how eHeal works. And coming to USEC, the doctors can upload their images to USEC to get a processed image so that their diagnosis can become a little bit easier and more sure as well. And coming to the admin part, the admin can receive documents for verification from the doctors, and also they can approve and update their profile details in the MongoDB as well. And ultimately, the documents are needed to be stored in the S3 bucket. So this is how the sequence of things are done. Next. So coming to the state diagram, basically the user once the user logs in as a doctor, as a patient, we can determine their states over here. So here we have the yellow boxes and the blue boxes as well. So the yellow boxes, they signify the stages of the patient. So initially the patient can complete their initial assessment using the eHeal, UHeal. When the assessment is done, if they need a further diagnosis, they can schedule an appointment with the doctor, or else if they are satisfied with that, then they can receive the diagnosis. If they're not satisfied, they can again go and try to do the assessment once again. They might get a better result this point in time. And coming to the blue boxes, those are related to the doctor. So once the appointment scheduling is done, they can receive their appointment details. If the patient uploads the images, then they can receive the appointment details with those images, so that these images can be uploaded to USEC. If the images are not present, still the doctor can see the patient's record based on their one card. So still the doctor would be able to diagnose the particular patient. When everything is done, they can send the report, and the patients ultimately receive the report, and then we'll be going to the logout stage. Those is our state diagram. And coming to the class diagram, so patient, doctor, and insurance, as a point of view, the entities we are considering are these three. The patient has the patient ID, age, gender, weight, and health issues as well, and the patient images as well. Images in the sense they might be the images they upload, or maybe the profile images as well. Similarly, for the doctor has a doctor ID, doctor specialization, doctor experience, and the verification status as well. And the insurance has an insurance ID, the provider name, and the start date and the end date.
Yeah, coming to sprint one recap, in sprint one, we built the core features for patients, doctors, and admins. We added sign up and login via email, phone, or social media, and allowed patients to manage their profiles and insurance details. And coming to doctors could register and submit credentials, while admins could review and approve them using their admin dashboard. After approval, doctors could access their dashboards. And we also integrated AI heat maps, segmentation for better diagnostics. And for this sprint, we had total of 31 points. We completed all of them.
When it comes to product backlog, I will give a quick overview for time being. Basically, we design our product backlog based on the user stories we got, like patient perspective, doctor perspective, and admin perspective. What we will cover is based on the user stories. It will check all the needs of the user stories in our product backlog, like booking appointments, booking appointments, and like that, like similarly applications like useg, uheal, like this, we will cover everything in our product backlog for getting each and every aspect for the user stories to get from our application. Yeah, simply this is about the product backlog. Yeah.
Yeah, coming to sprint to user stories, we focused on enhancing the patient experience by implementing 15 key user stories. In user story 2, we introduced a password reset functionality, allowing patients to securely reset their password via email verification. And coming to user story 3, enable patient profile management, where users can create and update their personal details, medical history, and insurance information for long-term record keeping. User story 5 allows patients to upload and store medical reports, which can be accessed or downloaded securely. In user story 6, we made it possible for patients to share selected medical records with doctors, helping improvement diagnosis quality. To streamline bookings, US Story 7 introduced appointment scheduling via UHIL, where patients can select a doctor, date, and time with confirmation. Finally, US Story 8 added the flexibility to choose between virtual and in-person consultations during appointment bookings. These stories collectively contribute to a more personal secure. In US Story 9, we implemented appointment confirmation via email or SMS ensuring patient receive instant booking updates. US Story 10 Your Story 10 allows patients to reschedule or cancel appointments with confirmation and a valid reason, giving them more flexibility. For intelligent healthcare assistants, Your Story 13 introduced an AI-based preliminary diagnosis feature where the system suggests potential conditions based on symptoms. Building on that, Your Story 16 uses those symptoms to recommend suitable doctors through AI suggestions. On the doctor side, US Story 19 enables them to manage their profiles, including specialty availability and preferences, ensuring their information stays accurate and up to date. USA 20 provides doctors with a dashboard view of their upcoming and past appointments, organized by the date and time. Coming to US 21, doctors were given the ability to write and update patients' health records and notes. The system securely saving all data stream and clinical documentations. US 22 enables doctors to upload and review medical images such as X-rays, MRIs, and CT scans, which are linked to specific patients for AI-based processing where UFEC significantly enhancing diagnostic capabilities. Lastly, US 25 introduces real-time notifications for doctors when a patient books, cancels, or misses an appointment, helping doctors stay informed and better manage their schedules. These additions strengthen the clinical functionality of the system and ensure smooth communication between patient and healthcare providers.
Yeah, coming to the test cases, these are the test cases we have done in this sprint. And coming to the first two test cases are regarding the password password reset. If the user forgot his password, he can reset the password. And we have successfully created written the test case for this. And coming to the third test case, this is regarding the patient profile update. And first patient need to log into his profile and he can upload his profile image and he can update his details. And we successfully written the test case for this also. And fourth test case was regarding the patient health records. So doctor can see the patient health records. We need to doctor need to log in and he should navigate to my patients and he can manage the patient records there. And first we have failed this one. We cannot get the patient details in doctor, and then we recheck the code and we can pass it and we have passed them. Next. And coming to the next test case, schedule an appointment with doctor. So as a patient, patient need to schedule an appointment. For that, he need to sign into the patient dashboard, and then he can visit the appointment page and click on the book, and he need to enter the details like time slot at which he need to appoint the doctor, and he can confirm. And we have passed this test case. And coming to the next case, book an appointment, and after that he need to the patient will be getting a verification confirmation through email after the appointment was scheduled, and we have passed this test case too. And then next was the reschedule. If the patient want to reschedule the appointment, he can click on the edit button and he can change the time slot. First we have failed, we cannot reschedule. The appointment does not get rescheduled, and after we can rejecting the code, we have passed this test case also. And next one is a cancel an existing appointment. If he need to cancel his appointment, he can cancel. He can go through the edit button and he can cancel the appointment whenever he want. And we have canceled that. We have passed this test case too. And next test case was the recommended doctors to the patient based on their conditions. So we have also passed this test case to the patient is shown in a list recommended doctors based on these conditions. Next. And next was the add medical history. As a patient, he can add his previous medical history on the patient dashboard, and we have passed this test case too. And next test case was the sign up as a doctor and verify book good appointments. As a doctor, he can see the appointments booked by the patient. He can see it in the doctor's dashboard. He can view the availability calendar and select the date. We have passed this test case too. And last test case was as a doctor, he can as a doctor, he receives a patient notification on the patient appointment. We have passed this test case too. Next.
Yeah, with respect to stories like completion and so we have actually with respect to doctors and patients, we have actually done majority of the part when comes to creating the profiles and updating the for example when you go to patient uploading the insurance part and uploading the uh, doctor availability part, we have finished them, we have tested them in a proper way. But like we also receive the notifications, and that's also like it's been completed. Like when the user is booking an appointment, or the doctor, the we need to intimate the doctor that your time slot has been booked with this particular patient. So that is also been done. And coming to seeing the appointments and managing them, like updating the appointments, it's also like been in the completion state. And now coming to not completed, so as you see, like I want to store my past medical assessments and reports and for to future references. So assessments, like it's actually has a tie-up with the chatbot team. We have some issues with respect to like connecting that with respect to in the front end side. So we uh, we want to make sure that it's not going to be happening in our next sprint. And virtual appointments and in-person meetings are option. And so we haven't said that it's finished, because like the virtual appointment opportunity is like creating a platform where doctor and patient can directly virtually can connect it. So in this one is like a very big task for us. So we predicted that it's going to be completed in this sprint, but it's not done. And coming to uploading the X-rays and MRIs, so it's also still has a dependency on the ML team. So ML team, and we the ML team actually they have done this part, but we actually didn't get the time to have a look into this. So maybe in the next one we can finish this one too. Yeah.
Yeah, so this is our team velocity chart. In sprint 2, our team achieved velocity of 29 story points out of 36, which were assigned to us. The sprint points that we had to achieve higher historical points that were assigned in sprint 0 and sprint 1. As you can see, we were able to complete 29 story points out of 36 in this sprint. In sprint 1, our story points were 19, and sprint 2, the story points were 31, which we completed. But due to some reasons, this sprint we were not able to maintain consistency. So next slide. Okay, so the reasons that we were not able to achieve the story points, I'll explain on this slide. This is a burn down chart. The blue line represents the ideal burn down, and the orange line is our actual burn down. That is the actual progress made by our team. And if all went as planned, we were supposed to get reduced workload, but due to some reasons, we were not able to achieve the points on the assigned day. As you can see, uh, that starting March 11 to March 13, there was no work done because all the group members took a break from work, which we had a break from the last sprint, which the work we completed from the last sprint, we took a break. On March 13th, team members work on their assigned tasks, but from March 13 to March 16, group members took their days off because of the Holi festival. And then on March 16 evening, everyone resumed their work till March 19. Um, we also had a spring break, so the spring break was from March 16 to March 23rd. So as you can see that during these days, the members of the team were doing their work as per their time schedule. So because some members agreed to work during the spring break, or some members did not, so we kind of lagged over there. As you can see, 18th of March and from 20th to 23rd of March, no work is being done, as most of the team members were on vacation due to the spring break. And the rest of the days, all the team members were working on their part. In the middle, a person took a day off because they were sick. Due to the breaks and all the other reasons, festival and everything, we were not able to achieve the complete story points that were targeted. But at the end, we will achieve because as a team, we support each other and try to help each other as much as possible. Okay, so yeah, so next slide. This is our committed ratio, and for the sprint 2, our committed ratio is 100%. But as I mentioned the reasons earlier, uh, we were able to achieve only 81% of that. We were not able to complete some tasks. As you can see in the previous sprints, we were able to complete all the tasks assigned and get 100% ratio, but this time we were not able to complete all the tasks. We had assigned 36 story points and were able to complete 29 story points out of 36. In sprint 0, we were assigned 19 story points, as you can see, and we completed all the story points, giving us 100%. In also followed by the sprint 1, 31 story points were assigned and we completed all the story points. As I mentioned earlier, in sprint 2, because of some reasons, we were not able to we were not able to achieve all the assigned tasks. So we are 20% behind the schedule, but we will complete the remaining tasks. Yeah.
So coming to the sprint 3 planning, so these are the summed up stories that have been left out or we haven't been able to complete in the previous sprint. So I'll just give a brief briefing about these particular stories. So there's a part that is left out, that's the integration part. Coming to the individual works, the ML and AI part is done and the full stack part also looks in a good shape, but we are finding it a little bit difficult and a little bit tedious to integrate both the parts. We are currently working on that, and as we can see, as a patient, we would want to make the patient's dashboard to be more dynamic and more responsive at this point in time. So we want to make the integration as quickly as possible and also as dynamic as possible. So these are the stories which we have narrowed down. As a patient, we want to view the appointments and also prescriptions in the profile as well, and also uh, check the doctor's availability, specialties, and location as well, and also want to see the ratings and the reviews of the particular doctors. So that's an important feature we would like to improve. So that's why we have assigned 5 story points for that. And as a patient, you want to join a video call. This is a big feature considering we need to make a video call system between the doctor and the patient and also make it as live as possible. So that also we have given as 5 points. And also we want to get a potential diagnosis based on the biomedical images. That's the ultimate part of integrating doctor and the patient as well. So this also we consider it as an important feature. So we have pointed out to it to be 5 story points. Next. And the remaining story points are that we need to store the past medical assessments and reports for future reference. So ultimately, we want to put all these things on the one card so that accessing the entire medical reports and the medical assessments of the patient can be made a little bit easier, but it's a little bit tricky than what we expected during the framing of the product backlog. So I think that's one of the reasons it boils down itself to sprint 3. And also the other thing is that we want to uh, implement a feature so that the doctor can seamlessly upload the medical images, so that the processing can be done. So these are few points that are left out and the user stories which are related to the sprint 3 planning. So we will do our planning accordingly to complete the uh, pointed out user stories. Yeah.
Yeah, so now comes to like project demo. Like we actually shown the entire demo in a specific video, but I will go through the basic images. Like, so basically, once you have visited our application, so you can choose a role, whatever you want to. Like, so what I mean, like, as a doctor, you can choose a doctor, and the patient, as you can choose a patient role, and then we are actually showing the patient dashboard in this way, but this is actually updated. And with respect to patient profile and insurance details, we also had a new UI. So that's going to be in the next in the upcoming commit. So you can go to next slide. Yeah. So yeah, so this is the new view of the patient dashboard which we want to show here. So here you can see like booking an appointment, news at the top, and we also have on the right side like there is a one card system where we are actually showing up the age, height, the gender, and then the weight of the person. And we are also showing the recent medical history, which we can show up, and the appointments with respect to appointments. So we are showing the appointments which are actually booked, and you can go to the next slide. Here there is a doctor's profile. So doctor's profile where doctors actually can create the profile to our platform, and then once they created the profile, they can actually create the availability date. So this is like completely explained in the demo how it is actually been set up, and but with this calendar, like you can observe like he's been available from 15th to 30th, and out of which 23rd he has an date where there is an appointment. That's why we are showing it as in the yellow color. Yeah. Next. So this is where we can actually update the profile of the doctor, and so here they can update their full name, specifications, and if they want to upload the verification document, that can also be done. So yeah, next one. So this is how the doctor availability, that's what I was trying to claim, that we can add the availability, and then we can show up that the Tuesday, Wednesday, like on what days they want to, and they can modify that. Next one. So this is our Uspark backend APIs, where the things you can go and test through. So we are using Swagger for API documentation. So why? Because Swagger is better, like when compared to using our own text files to share, saying that like this API will work. Here you can test it, you can provide the authorization token, and then you can start using the APIs right away. Yeah. Can you go to next? So this is like one more like a page where we are trying to show like what are the APIs which we are having. Like we have the post request, get request, appointments, authentications, admin pages, extra, etc. Yeah, you can go to the next one. And this is the wiki page where you can find out like all the links of our application and all the like details which you want to, and you can find the code over there. And yeah, that's it. Yeah, thank you.
Thank
Thanks
you.
everyone.
Thank you.
Thank you.